Generalist AI has announced GEN-0. And what makes this different from everything else you've heard about is how it learns. While most robot AI systems train on simulations or videos scraped from the internet, GEN-0 was trained on something far more powerful. 270,000 hours of real robots, manipulating real objects in real homes and warehouses. That's over 30 years of continuous robot experience, and they're adding 10,000 more hours every single week. Here's why this matters. For years, researchers have been stuck on a fundamental problem. Language models like ChatGPT got incredibly smart because we discovered scaling laws. Add more data and computing power, and they predictably get better. But robots couldn't do this. They would learn one task well, then struggle with anything new. They couldn't generalize. Generalist AI claims they've cracked this code for physical intelligence. Their research shows that when robot models reach 7 billion parameters and are fed massive amounts of real-world data, something remarkable happens. They call it a phase transition or an intelligence threshold. Below this point, at 1 billion parameters, the models actually stop learning. Their digital brains become rigid, unable to absorb new physical skills. But cross that 7 billion parameter line with enough real-world training, and suddenly these robots start displaying genuine adaptability. The architecture behind GEN-0 is called Harmonic Reasoning. Think of it as a brain designed specifically for physical tasks, not just borrowed from language models. It processes the continuous stream of sensory data that robots experience, the visual input, the force feedback, spatial awareness, everything happening in real time. And because it's trained on such diverse real-world scenarios, from delicate assembly work to heavy lifting, from cluttered kitchens to organized warehouses, GEN-0 can transfer skills across different situations with remarkably little additional training. The company tested this on robots with different body types, some with 6 degrees of freedom, others with 16 or more, and the same foundation model worked across all of them. But let me tell you what's really fascinating about their data operation. To gather 270,000 hours of manipulation data, they built custom hardware and infrastructure. They installed dedicated internet lines at thousands of locations worldwide just to handle the bandwidth needed to stream all this robot experience back to their training systems. Every week, 10,000 new hours flow in. That's the equivalent of over a year of human experience being added every single week. This isn't a research project, testing a few demos in a lab. This is industrial-scale data collection happening right now in actual working environments. The implications go way beyond just better robots. If Generalist AI's scaling laws hold up and their research suggests they do, then we finally have a roadmap for building general-purpose robots the same way we built general-purpose language models. You can actually calculate how much real-world data you need to reach a specific performance level, can predict how much additional training will reduce errors on new tasks. This turns robot development from an art into an engineering discipline with clear metrics and predictable outcomes. Now, some companies are taking different approaches. NVIDIA's Project GROOT focuses on humanoid robots and uses a mix of simulation and real data. Physical Intelligence released their PIO model that can be fine-tuned with as little as 1 to 20 hours of demonstration data. But Generalist AI is making a bold bet that massive-scale real-world training is the only path to truly general robots. They're essentially saying that physical intelligence can't be shortcut through simulation or transfer learning from internet videos. You have to get your hands dirty, or rather your robot hands dirty, in the messy, chaotic real world. The timing of this announcement is striking. We're seeing a convergence of technologies that have been developing separately for years. Transformer architectures from language models, diffusion models from image generation, massive compute infrastructure from cloud providers, and now finally, the ability to collect and process enormous amounts of real-world robot data. GEN-0 represents the first serious attempt to bring all of these together at the scale needed to make foundation models work for physical intelligence. Whether this specific model becomes the standard or inspires better approaches, one thing is clear. The race to build artificial general intelligence isn't just happening in data centers anymore. It's happening in warehouses, homes, and workshops around the world, where robots are learning to navigate our physical reality one manipulation at a time. Write down your questions and feedback in the comments section of the video. Like and subscribe for similar robotics content, then watch the next video that will appear in front of you soon. See you there.